Now we are going to solve the typical problem which is based on all above the chapter, that is vector algebra. So the first problem is, if magnitude of vector x is 2, magnitude of vector y is 4, magnitude of vector z is equal to 1 and vector x plus vector y plus vector z is equal to 0, then find vector x dot vector y plus y dot vector z plus vector z dot vector x is equal to what? What will the value of this? Now the solution is, as we have magnitude x, magnitude y, magnitude z and x plus y plus z is equal to 0, just we take vector x plus vector y plus vector z whole square. That is vector x plus vector y plus vector z into vector x plus vector y plus vector z. That is mod x square is equal to x dot x. We know that. So we will multiply this vector x into vector into vector y, vector x into vector z. Now the turn of vector y, that will give vector y into vector x plus vector y into vector y plus vector y into vector z plus, now the turn of vector z, vector z dot vector x, vector z dot vector y plus vector z dot vector z. Now as we have x dot x, that is modulus x square, y dot y, that is modulus y square, z dot z, that is modulus z square. And as we know that x dot y is equal to y dot x, so it becomes 2 times x dot y. Similarly, it becomes 2 times x dot z plus 2 times y dot z. And in the left hand side we have vector x plus vector y plus vector z mod square. As vector x plus vector y plus vector z is 0, so 0 square is 0. Mod x is 2 square, that is 4 square, that is 1 square, plus 2 times vector x dot y plus vector y dot z plus vector z dot x or x dot z, that's a wish because it is commutative. So we get 0 is equal to 4 plus 16 plus 1 plus 2 times vector x dot y plus y dot z plus z dot x. So we get 21. 21 will be gone left hand side, x dot y, y dot z, z dot x is equal to minus 21. So we get vector x dot y plus y dot z plus z dot x is equal to minus 21 by 2. That was our required answer. Now the next problem is, that is problem number 2. Express vector x is equal to 3i minus j plus 2k as a sum of two vectors, vector a and b, such that vector a is parallel to y and vector b is perpendicular to vector y, where vector y is equal to 2i minus k. Now in this we have to express x as a sum of these two vectors and we have two conditions. as we have vector A is parallel to vector y. So, vector A is equal to m times vector y, where m belongs to r minus 0, that is m is not equal to 0. Therefore, vector A is equal to m times vector y, that is 2I minus k, or we can write 2mi minus m times k, or we can write 2m comma 0 comma minus m, that represent vector A. Now, as we know, vector F can be represented as a sum of vector A plus vector B. Therefore, vector B is equal to vector x minus vector A. Vector x is 3, minus 1 and 2, and vector A is 2m, 0, minus m. So we get vector B is 3 minus 2m, comma minus 1 minus 0 minus 1. 2 minus or minus m is 2 plus m. So these are the coordinates of components of vector B. Now we have second condition. Vector B is perpendicular to vector y. That implies dot product of vector B and y is 0. That is, vector B is 3 minus 2m, comma minus m, comma 2 plus m into vector y, that is 2 comma 0 comma minus 1 is equal to 0. That gives 6 minus 4m plus 0 minus 2 minus m is equal to 0. That is 4 minus 5m is equal to 0. That gives m is equal to 4 over 5. Therefore, we can find vector A. Vector A is now 8 by 5 vector I minus 4 by 5 vector k. And we can also find vector B, that is 3 minus 2 times vector m, that is I part, minus j, as it does not involve m, and 2 plus m means 2 plus 4 over 5 k. So we get vector I as 7 by 5 I minus j plus 14 over 5 k. Now we can write x as, and we will check, as x is represented at a plus b. So we write a plus b here. That is 8 by 5 comma minus 4 by 5 k plus vector b is 7 by 5 comma minus 1 comma 14 by 5. So we get 8 by 5 plus 7 by 5, that is 15 by 5, that gives 3. 0 minus 1 is minus 1. Minus 4 by 5 plus 14 by 5 gives 10 by 5. 10 by 5 is 2. That is same as the given vector, that is 3i minus j plus 2k. Therefore, result is true. Vector x can be represented as sum of two vectors a and b. Now the next problem is, prove that cross product of vector a with vector a cross b is equal to modulus a square cross product of b cross a. So we have to prove this. Now the solution is, we will take first of all left hand side, that is vector a cross product vector a cross product cross product of vector A with B. So first we apply the formula with, this is considered as vector X, vector Y, vector Z. So we'll use the formula first with third, that is dot product of A dot A cross B outside vector Y minus first with second X dot Y outside vector Z. So we get, as we know that AAB, if two vectors in a scalar triple product are same, then it is 0. So it will become 0 and A dot A is modulus A square. That is a property of dot product. So we get this is equal to 0, 0 into vector A minus mod A square A cross B. So as we know that A cross B is equal to minus of B cross A. So it becomes like this. So there are two minus in the problem. So minus minus become plus and we get mod A square into B cross A, which is equal to right hand side. That is our required result. Now the problem fourth is for non-zero vectors, vector A, vector B, vector C, if A cross B is equal to C, B cross C is equal to A, then prove that magnitude of vector B is 1. So we have to find magnitude of vector B is equal to 1 from above these two relations. As we know that B cross C is equal to vector A, now we will take the dot product of vector B applying on right hand side of both these equality. So it becomes B cross C dot B is equal to A dot B. That is, we know that scalar triple product will become 0 when two vectors are same. So that implies A dot B is equal to 0. So from the first condition we get another condition, A dot B is equal to 0. Also B cross C is equal to vector A. That is, B cross C is equal to, we will substitute here the value of C, that is A cross B. So we get, by using the rule first into third outside second minus first into second outside third, which is equal to vector A. As we know that A dot B is equal to B dot A, therefore we will get here this is 0 and B dot B is modulus B square vector A minus 0 vector B is equal to vector A. So we get modulus B square into vector A is equal to vector A. So we get modulus B square vector A minus vector A is equal to 0. So we get vector A as common and in the bracket vector B modulus square minus 1 is equal to 0. As it is given vector A is non-zero vector, therefore modulus b square minus 1 is equal to 0. That implies modulus b square is equal to 1. That implies modulus b is equal to 1 because modulus value is always positive. Now the next problem is A is 1, 1, 2, B is 2, 3, 5 and C is 1, 3, 4 and D is 0, 1, 1 are the vertices of a parallelogram ABCD. Find its area. As we have the vertices of a parallelogram, that is A, B, C, D. We have four vertices of a parallelogram. So we have to find the sides AB and BC of a parallelogram to get its area. So we will get the position vector of AB. A is 2, 3, 5 minus B is 1, 1, 2. AB, that is B minus A. Position vector of B minus position vector of A. So we get 1, 2, 3. 2 minus 1, 3 minus 1 and 5 minus 2. Similarly, we will get BC. So position vector of C is 1, 3, 4 minus position vector of B is 2, 3, 5. So we get minus 1, 0 and minus 1 as the direction of, or we can say position vector of line BC. That is a vector along BC. So we get two vectors along two adjacent sides of a parallelogram. Therefore, area of parallelogram ABCD is equal to modulus of vector AB cross vector BC, that is a cross product. So we write here that is vector AB is 1, 2 and 3 cross product BC is minus 1, 0, minus 1. On solving we get that is minus 2 minus 0, comma 3 minus 1, comma 0 plus 2 by making its determinant. We know how can we find out the cross product of two vectors. So we get minus 2, 2 and 2. Now we have to find the magnitude of this to get area of parallelogram. Therefore, area of a parallelogram is under root minus 2 square plus 2 square plus 2 square, that is under root 4 plus 4 plus 4, that is under root 12, that is 2 into 2 4, 4 into 3 12, that is 2 under root 3. That is the required area of a parallelogram when we know corresponding vector with the two adjacent sides of a parallelogram. Now the next problem is, that is problem 6. If alpha, beta, gamma are the direction angles of vector x, prove that sin square alpha plus sin square beta plus sin square gamma is equal to 2, and also find that or find the value of cos 2 alpha plus cos 2 beta plus cos 2 gamma. Now we have to prove that sin square alpha plus sin square beta plus sin square gamma is equal to 2. As we know that if alpha, beta, gamma are directions angle of vector x, then we know the property cos square alpha plus cos square beta plus cos square gamma is equal to 1. Cos square alpha is 1 minus sin square alpha. Cos square beta is 1 minus sin square beta. Cos square gamma is 1 minus sin square gamma is equal to 1. By the identity sin square plus cos square is equal to 1. So we get 3 minus sin square alpha minus sin square beta minus sin square gamma is equal to 1. So we get sin square alpha plus sin square beta plus sin square gamma is equal to 3 minus 1 by changing the position of this and 1. So we get sin square alpha plus sin square beta plus sin square gamma is equal to 2, which is our required result. Now we have to find the value of cos 2 alpha, cos 2 beta and cos 2 gamma. As we know that sin square alpha is equal to 1 minus cos 2 alpha by 2, that is the formula of cos 2 theta. Similarly, sin square beta is equal to 1 minus cos 2 beta over 2. Similarly, sin square gamma is equal to 1 minus cos 2 gamma over 2. And as we proved, sin square alpha plus sin square beta plus sin square gamma is equal to 2. We substitute the value of sin square alpha, that is 1 minus cos 2 alpha over 2, sin square beta 1 minus cos 2 beta over 2, sin square gamma 1 minus cos 2 gamma over 2 is equal to 2. So we get 1 minus cos 2 alpha plus 1 minus cos 2 beta plus 1 minus cos 2 gamma is equal to 2 into 2 is 4. So we get 3 minus cos 2 alpha minus cos 2 beta minus cos 2 gamma is equal to 4. So we get, by changing the position, cos 2 alpha plus cos 2 beta plus cos 2 gamma is equal to 3 minus 4. So we get the value of cos 2 alpha plus cos 2 beta plus cos 2 gamma is equal to minus 1, which is the required answer. Now the next problem is, vector A is a unit vector and vector B is 3, 0, minus 4. The measure of angle between them is pi by 6 if the diagonals of the parallelogram are 3 times vector A plus vector B and vector A plus 3 times vector B, then obtain the area of parallelogram. So we have diagonal here, and we know that if we have diagonal, then area of a parallelogram is half the product of two diagonals. So area of a parallelogram is equal to half the product of two vectors, 3 times A vector plus B into A plus 3 times vector B, that is the cross product. So we get half, it becomes 3 times A cross A plus 3 into 3, 9 times A cross B plus B cross A plus 3 is common out, B cross B. Magnitude. As we know that cross product of two similar vector is 0. So cross product of A cross A is 0 and cross product of B cross B is 0. And we get in the magnitude form 9 times A cross B and B cross A becomes minus A cross B. So we get here half times 8 times A cross B magnitude. At magnitude of 8 is 8, so it becomes 8 over 4 magnitude A cross B. So we get 2 times magnitude of A cross B. And also we know that magnitude of A cross B is magnitude A into magnitude B sine of angle between vector A and vector B. That is, magnitude of vector A cross B is, as vector A is a unit vector, so its magnitude is 1. Vector B is given as 304, so its magnitude is 3 square plus 0 square plus 4 minus 4 square into sine of angle. Angle is pi by 6 in between them. So we get 1 into 3 square is 9 plus 16 into sine of angle is 1 by 2. So we get under root 25 into 1 by 2. Under root 25 is 5 as it is a magnitude, so we take only positive sign. As we get value of magnitude A cross B, therefore area of parallelogram is equal to 4 times magnitude A cross B become 4 into 5 by 2. 2 times 4, so it becomes 2 into 5. That is, we get area of parallelogram is 10. So it was all about the chapter Vector Algebra, where we learn about the vector, its property, its dot product, cross product of two vectors, scalar triple product of vectors, vector triple product of vector, area of parallelogram, area of triangle, area of parallelepiped, direction cosine, direction vector, direction ratios, and how can we find out and use triangle of inequality and so many identities. So this was all about the vector algebra chapter.